Let's see if our front end or our app still works. Because here we have the counter account, and here we're calling it set. And I don't know if I just forgot to update the IDL or when I deployed some changes. Let's see. Nope. Nope. To personal. Let's go. We already got our counter, but only because we get it from. We create it here from our public key, but that should happen on smart contract level, so new key. And then on the component, we need to remove earth. Prepare from seed, the data account public. Create counter. Yeah. So and the public key changes. No, I don't want this. Okay, yeah, right. We can initiate a counter. Let's see. Initiating. Worked. Why did it work? Here it wants user, system program, and counter account. We're providing it with Z? Where does the Z come from? I don't get it. We have the counter, initialize, count, set. Yeah, no, that's wrong. But it still worked, because it doesn't care about the name of the argument and the length of the bytes used is the same, so it doesn't matter. Okay, let's see. Export again, export. My connection is ends. Count ID. So, get an error, please. Okay. So, okay, the key name actually doesn't matter. Let's see. We can still okay, so we can initialize and it's called, what's the background? We changed to, let's fix that. Initiate counter. Reverted. Why? Other functions are not super. What the fuck? That's new. And what we have? It's deployed. We got the latest IDL and it should work. Why isn't it working? Refresh again. So we don't. Where's the component? We don't have a counter, so that's why there isn't anything shown. But data account public key isn't set anyway. Yeah, it's null or undefined. And has counter, has counter, set data account. Okay, set true here if we can fetch the PDA. Data account public key. Okay, is set here, so we have it here. We have the IDL. We have the right public key of the counter 7A. Okay. Nope. Why? Why has this changed? I don't get it. Okay, let's copy that. Let's paste the program ID. Alright. So we have the latest program ID, the IDL, and we're passing the right params to the sphere public key, a public key, and a public key. We have create. We have a public key. We have the user as a public key, and the program ID as public key, of course. So let's see. I hope you can even understand me. Initiate counter. The button is not disabled. It triggers phantom. The transaction does not revert in the simulation. Confirm. We created a counter with... Okay, that's probably a reg error. Buffer in the P component. Ooh, I wanna see where it comes from. S. Okay, the create counter worked. We don't have the log here, so we created the account, we logged the hash, the public key. Okay, that's all we want. So we created a counter with that public key. And the public key of the PDA is random because we create a new key pair. So anyone should be able to interact with that counter. If we know has counter is true and the public key is new public key, then we should be able to know why are these disabled, because you have to get the data first to get it enabled, and that's let's say if the connection or wallet changes, then I should be able to trigger the data load by what the fuck? Okay, it doesn't. It does come from the get data because it gets now triggered after 2 seconds. Okay, so remove that here. It's the get data thing that data account pub key. We have one, so we don't return. Set data account. We don't interact with any React here. Like we get the program. That should work. This catches the error. Console log PDA account. PDA. We get the account. No error until here. So let's remove that and remove those two. Now it should work. Okay, we set that At least no error. We get the data account, so we get in here. Set data account is probably no, we don't. Set has counter. Has data account. No error. So what does set counter? That has counter. Has counter is true by default. So, and we set it to true. Yeah, okay, so we don't need it. At least now we have a counter. Data account. Okay, but we have a data account now. Why are these disabled? So, that data account. So let's see. Okay, we don't get in here anymore, so we say on connect wallet 1, 2. So with the set data account, we go here, and this causes the error. 1 set data account, 2, and we don't have the error. So it's set data account. Why? Set data account. Now we have a data account, and data account is only used here. This let's remove this for now. 1, 2. The buttons got enabled. Why the fuck does this kind of type has it? Count? Yeah, okay. Count is a big number. And it can be locked. Why the fuck? Data account. Account. Punkt number or something? Is this one? Ooh, okay. Nice. I don't know why, but at least. So, this should work now too. 1, 2, bam. In programs methods dot increase counter. When did I change those things? This isn't my account. Oh, this is mine. This isn't mine. This isn't mine. This is mine. Okay. Initializing. And we still have to set probably. Yeah, it's still called set. Okay. Now everything makes sense. So what have we changed? We can remove. Do we want to remove this? This is still set. Okay, it now makes sense why the program ID changed. We added this late. What have you all changed? Changes. Okay, this is fine for now. We have to check the and let's build counter. Nope, count. Okay, we fixed the typo and let's just deploy it to make sure. So program ID. Counter. That's it. It's deploying. Oh, okay. The internet connection is really bad. Deployed, export IDL, copy IDL. Paste IDL. Oh. Okay. We now should be able, everything should be fine. Let's refresh. Initiate counter is disabled. Why? Because we have this move and we don't have a counter. False. Yep. So initiate the counter. Approve. Initiate the counter. Okay. We loaded the PDA, so the count is currently null. Or 0, sorry. Let's increase it. 1, 2. What's callback here? No, okay. This works, but theoretically we can paste here any PDA public key, and then we can modify any PDA. We don't want that, so we set the seeds of our account. Okay, we have the init, we have the payer, we have the space. We have the init, we have the payer, we have the space. That's fine. Let's see. Yeah, do that in extreme. So then the seeds. That seeds like this. Counter. So I think we wouldn't need that only if we have but for now we use it. Then we use the admin. So the admin is the signer.key.sref. So we use the signer, it's a user for us, .key.sref, I think. Key.sref. Bam. Here. Yeah. Why isn't it key.sref? Key.sref. Yeah, I don't know. So we used it's probably public key. Okay, so in this array we use these. We now have bytes in this array which are used to generate the public key of the PDA. And so this is for everyone the same, of course, but we have then here the public key of the signer. So you won't be able to use any public key here because it must be from the signer, so you must have the private key, of course, to sign the transaction. But I think, since this is only the reference we use here later to initialize the account, we probably have to okay, so for mutating, can we do the same? So we mutate and then we set the seed of the account we wanna mutate to the counter. Okay, we don't have a signer here. How do we do that? Okay, now ignore this one now. Let's see if it builds. Yeah. And next one. Cat4. Wipe up is that? Do we need to call it like that? No. Add missing generic argument. Oh. How does he do that?
Here, this one still corresponds to this one. Admin must sign, and this account must be present. That's the important thing. That's how we check that an admin is actually an admin, because an admin is only an admin if it has an admin account. Wait, this is right. So the opposite way of what we did yesterday in the last episode, because there, if the account existed, then we said this is already done, and here we say only if that account exists are you allowed to proceed. Because if this account doesn't exist and I have it
Okay. So we add the same thing to our counter. Let's add the same thing. Bump, the right bump, right? But mid peak, of course. That's what still doesn't want it. So we use this for the this count. Okay, so the counter. So we don't need to. Oh. Okay, so we should only be able to call our counter now. Let's wait. Okay, we have to add the admin here again as well. Admin is the signer. So we just say we have the user here as well. And this should work. course. So just probably nope. Info counter. Okay, as you said.
Mutable here, and it doesn't find such a user account here for the admin account, then here it will say a constraint is violated. Anchor does the check for me.
Doesn't find. Okay, what's the one? No. Let's try this. Hold on, streaming. Half an hour, okay, that's it. Okay. Okay. Let's call it. Let's call it get counter. So we have the user, which is designer. We have this thing here, but let's say I want to mutate account and don't initialize a new one. And our counter is program info type counter. Okay. No, we just put this in update counter. Okay, perfect. So we can get rid of this. Let's see. Please. No. Gets error. Ooh! Okay, nice. So we export the new IDL and let's deploy this thing. Program ID is 53. That's 3 yet. at least the sound isn't laggy, but oh, the connection will lose a lot of frames. But it's deployed. It's deployed. We have the PDA account security by using user's key in the seed creation for the PDA. PDA, so far as I understand it, is program data account, because it's basically a own account living on a blockchain, but it's only utilized to store data for a program. And only the program can write to it, I think. I hope so. But let's see if we need anything to change. Or can we increase the counter? Probably not, because we are now searching for a counter for a PDA with the public key of our signer, which is my wallet. If that isn't, now we definitely won't find anything, because we have the prefix B counter, so there can't be a PDA currently. So let's try this, and we should get an error, hopefully. This reverts. Now I would like to know why it reverts. Yeah, constraint seeds. So with the seeds we provided, we don't have a PDA, so I would expect another or different error message, but let's see, we can't refresh. So we initiate a counter, why does this revert? Let's check how the test does it, early test. So to initialize we have data, yeah, we don't need it. We have the new account, we have the signer, wait, initialize set user system. Initialize set user system and the signer. Can we remove the signer? No, it still wants the signer, and it still takes a new account public key. A new account pair even. So theoretically we would still be able to change any counter PDA. Oh god. So set did in the last iteration or last deployment, it set the public key of the PDA. Why do we have it? Just give me headache. So we want to see the initialize. Yeah, no. So I have the user as designer, and this will be used to create the seeds for the PDA. And the PDA then is the user account type. Okay, I think here we could, no. Could we still here edit if we are a user, mutate any user account, but no admin accounts, because it's linked to the type here, so we can only, oh man. Can we initialize? Okay, let's try it here first. We want to initialize a random thing. User RV test. As its constraint was violated. Why? Okay. Yes, thanks. So account mutate, then we have designer, then we have the system program, and the thing and the type of our PDA or account. Yep, build this thing. Build, deploy. Hello? Yes. Okay, let's initialize. We have a random public key here. The user designer RV of our wallet. System program, of course. Yep. Why the fuck? Do you want different? Current wallet? Nope. Oh man. So initialize isn't working. Why is initialize not working? Oh, A seeds constraint was violated. Yeah, but why? Okay, let's try it. We have the new IDL. We have set user and system program. We have set user and system program. Count account is a new key pair. And we provide designer, which is this new key pair. I'm a bit confused now, but let's see. Initiate a counter. Yeah, why, bro? Let's do this here. We're in DevNet still, we have Sol. So let's fucking create a counter. Why does it okay, at least... Oh man! Because of the signature error? No error at all? What's the same? Let's close this. Revert it. Unknown signer. Yeah, I know. I know.
The name. Man, I keep forgetting how those functions are called. It was S, but you know, a user can have a different name. We add that as a seed, and then a user can have several user accounts. Perfect. Exactly what I want. We copy a sign up, user sign up accounts, and literally all the user sign up does in this case is create the account, and then it could write something into the account, but like all of a user account. Once I have a user account,
So KP is keeper probably.
I can do user stuff. Again, I need to provide the name, not the system program, because it doesn't need that anymore. And then I can also log this transaction. And yeah, that's the intended stuff. Let's execute that to see if that works. Now this is slow, but at least my video is fluid. Gotta set priorities. Literally, user account creation has worked, and doing user stuff also worked. 66. There we go. So if we this is the program from yesterday, from the last episode. Doing here, those kind of errors can come in many shapes. And make this user account. I don't know what's gonna be in there, but definitely the user and some, I don't know, user data, who cares. This is whatever the user needs, right? And then we're gonna do an admin sign up. This takes an admin. This time we're gonna let Anchor do it. Init payer is the admin himself. Space is 8 plus 32 plus 1. For now, because I'm too lazy to write good. What else do I need? The system program. That's there. Okay, cool. And for the admin account, we use the seeds. This is a user admin because it administers the users or whatever. And we put the admin as key as ref also because there can be several admins. So I want to put the admin here as well. But every address can only have one admin account, so I don't put anything else there except the static user admin thing that should distinguish it from like other PDAs. Cool. Bump we don't provide, we learned that last time. We use the canonical bump. Okay, and this will then be a normal account, and since the admin is also a user, I will give it the user account. Admin. Specified constraint must be used. So you're complaining down here that up here that needs to be SSL. Sure. We make this sign up immutable. Good. That's how the admin is created. And we assume that we have an admin sign up that takes those accounts. And we assume that
Admin sign up accounts. So we have initialize text exactly this, and then we have to set and counter and set the count 0. If this is exactly derived counts, instruction bumping. Why? No. What was it? Instruction bump you add in.
There is some kind of implementation here that does all the checks that only valid users are allowed to sign up as admin. We're not gonna call this one. That's why actually I'm just gonna error out of this. Damn it, how do I get to program errors? Oh, okay, fine, because I don't find them. I'll make my own errors. The public enum. I just throw it here. Error. Wait, error. Ah, god damn it, I just gotta look it up again. If I do it enough times, I will know it. Error code, and then here I can put that message. I'm not sure if I need to do that. Okay, but what's the problem then? Still, I'm just gonna see if it builds anyway. Yeah, builds anyway. It's just something with my local setup that doesn't. Whatever, it's just gonna do it. Anyway, I mean, this is all red, which I don't get why. Something my setup doesn't need to. Let's pretend those red lines are not here. And let's also pretend that this would be implemented and would do the certain checks that only real admins are allowed to have admin accounts. Moving on to a user account. Gonna do the exact same for a user. So user sign up accounts, and then the user account. And as for the seeds of this program, this one gets different seeds now, obviously, because otherwise the accounts would be the same. And such that they're not the same, we provide them with different seeds. This one is user and not user admin. So a completely different seed here. And we also take this one, but we say that each user, I mean that's a bad example. Anyway, we still do it like that. Each user is allowed to have several user accounts. Maybe they have different identity. You know, like with bubblegum, a user can create several rule sets.
I don't
Here,
get
the user can create several.
why this isn't
And
working.
to allow a user to have several such user accounts, we just add another seed here, like the name of this specific account. So we again add instruction data, the name, and then we just add the name. Man, I keep forgetting how those functions are called. It was S bytes. You know, a user can have a different name. We add that as a seed, and then a user can have several user accounts. Perfect. Exactly what I want. We copy a sign up, user sign up accounts, and literally all the user sign up does in this case is create the account, and then it could write something into the account, but like all I want to do right now is just return OK, because it's enough for me to just create the account. That's fine. That's the sign up, and then we'll do some function that actually does some stuff. How do we call it? Do stuff. Foo bar. I'm so creative. That's why I'm not an artist. Actually, let's make two separate functions to be more secure. One for the admin and one for the user. So let's make a do admin stuff. You have all the power to do stuff. And here we would do stuff that only admins allowed to do. But this is just an example, so essentially that's where we want to get to as a hacker. And then we would have a do user stuff, which haha insert Nelson. You're just a user. And then we do user.
So seed 1 is
admin,
counter
lots of
plus.
But yeah, I mean then essentially this is gonna be the same. I just realized I forgot something. I forgot to add the name here for the user sign up. Of course, needs to provide a name. User
Seed.
accounts.
Seed is
User do stuff accounts.
string.
Essentially, again, just a user. This time it does need to be mutable, and we don't init it anymore, but we still check that the seeds are provided. However, I think I would make it mutable. Probably want to do something with the user account. And we also don't need the system program anymore. And we do the exact same for the admin except this time not a sign up, and we don't need to have this one mutable, but we check that the admin is still the signer here. This one still corresponds to this one. Admin must sign, and this account must be present. That's the important thing. That's how we check that an admin is actually an admin, because an admin is only an admin if it has an admin account. Don't need the system program, right? So the opposite way of what we did yesterday in the last episode, because there, if the account existed, then we said this is already done, and here we say only if that account exists are you allowed to proceed. Because if this account doesn't exist, and I have it mutable here, and it doesn't find such a user account here for the admin account, then here it will say a constraint is violated. Anchor does the check for me. I could do it manually to check if the account is present, but Anchor does it for us. And we're sure that it's an admin account because we used the seeds for the admin. Let's see if that builds. Yeah, it builds. Okay. So, look at that. Just a little program with a bit of duplicated code. And my question to you, dear.
Instruction. Let's see how he actually calls
So
the
our
sign
user account
up.
is auto-derived because I have seeds on. So everything fine here. And then I just send this and I create my setup.
User and system program.
Local test validator.
He has user account, and system program.
Let's anchor deploy. Voila.
User account, and
And let's
system
go
program.
to our hack. Before we actually hack something, let's do the intended stuff, and then later we do a hack. So the way this is intended to be used is we call the method user sign up. We're going to sign ourselves up as a user with the name of my first user account or whatever. Yes, nice. And the accounts, yeah, this is pretty much the same as last time. We provide the user account. We don't even need to provide the system program because that's also auto-derived. And also our user account is auto-derived because I have seeds on. So
Let's see if this works. If this won't, I don't know. This has to be. But oh man, initiate count. Yeah, I could. But why? Okay, count. It's a public key. Yeah, that's admin sign-up accounts. User sign-up accounts. It's the same as we have. And then same for the same to initialize and same for the updating. So key pair file, okay, key pair file. So key pair is just a key pair loaded, so like my Phantom wallet. Right, so wallet becomes a wallet from that key pair. Using Anchor as well. Program ID, yep. Yep. So, and that's what I don't get. Can I open this in a new tab? Nope. Oh man. No. Nope, and nope, and so. Where the fuck was it? So slip. So we are doing a user sign up. We're doing a user sign up, so we need user sign up accounts, which takes in an admin account, system program, and an admin. But we only call it user and system program. So if we remove this and this, then we don't need to, we don't need to initialize this here, since the smart contract should do that. And the public key would be interesting. I mean, we should be able to create it based on the pattern, since we know it's counter plus the public key, but that's what we just tried and I didn't get it to 32 bytes. So let's do that for now. this has to be set not. Yeah, of course it's not provided. He can just ignore it as well. He has an admin account here as well. And doesn't provide it. And the admin account is just an account, yeah, like my counter. I don't get it. Yeah, we don't need the instruction, because for now we are fine with one PDA or one counter per user. So the user must be provided, and that's the sign. And he does this, so the user is his public key. So the user create counter is our public key. Create counter is our public key. Yeah. Public key. Since this takes a string, can we do set the new public key public key with counter plus, and we are taking in our, since we are the designer, yeah. Not only this will, of course, reverts, yeah. Why do we need to provide this set? I don't get it. We need to provide this set. So we're in the first idea. Set is mutable. Yeah, okay. System program is not mute. Initialize. And initialize needs the user, the set, and the system program. Okay. So I mean, he needs the same thing, system program info system. Let's just do where's my playground. And then I wanna see this. So this is basically the initialize. It's derive accounts. It's the user designer is account mutable or mutate. We have the account initializing, the payer is the user, the space is fine as well, and the seeds speed counter. We don't need the names bytes. User key as reference. The user account, or for us the counter account has I don't get it. Okay, that's exactly what we are doing. Yeah. Yep. And how do I... Oh, perfect. So, that's the way we would check if there's already a program address. A PDA. Yes, right. That's how we check if there's a PDA. And create user stats only needs a user and the user stats. Create user stats needs only user and user stats. Create user stats and only user and user stats. Oh! The user is designer. We are designer, our current wallet, user stats. From seed. Yeah, and how do I create a fucking seed? So the user is designer, the public key, and the user stats. The user stats are generated from a seed. Public key. Okay, let's do this first thing as a string, and it's called user minus stats. And then the second seed is the public key of the user, of the signer, of the current wallet. Generate. Bam! Okay. Okay. So, user stats is oh man, how do I do it in Anchor? How do I create a seed? Okay, nice, nice, nice. Oh man. Let's wrap it up. Oh. I can't even talk anymore. Let's wrap it up. It isn't exactly that what I think it is, because we're using seeds now for the PDA public key creation. But still anyone could use or find our public key basically and look up the prefix, or basically just by brute forcing, and then could change our PDA, or wouldn't that work? That wouldn't work because they can't be designer since they don't have the secret key, the private key. Okay. I think I got it. So no one else can now change my PDA since they can't be designer. And if they would put my public key in here but would sign with their wallet, this wouldn't match. Okay, okay, that's what I want to try out in the next session.